representations of integers. Very good. So they're using the quotient remainder theorem. Remember that we have n equals to dq plus r, and r is bounded, is sandwiched between 0 and d. Suppose I have an integer n, and I try to divide that integer by 2. It means that I have two scenarios. N is equal to 2q plus, well, in this case, d is equal to 2. So the remainder is in between 0 and 2. It means that my remainder is either 0 or it is 1. So I have 2q plus 0, or n can be written as 2q plus 1. Dividing any integer by 2 gives you 2q, or 2q plus 1. So n and d is equal to 2. What if I have an integer like n and start dividing that integer by 3, the next number? So now I have n and d is equal to 3. By quotient remainder theorem, d is equal to 3, right? So it means that the remainder is in between 0 and 3. What are the possibilities for the remainder? Remainder can be 0, remainder can be 1, remainder can be 2, dividing any number by 3. So here you have 3 options. N is 3q plus 0, n is 3q plus 1, n is 3q plus 2. Just a simple division. What if I generalize the idea? Now, what if I divide the integer by 4? Okay. Again, using quotient remainder theorem, now your d is equal to 4. So the remainder is bounded between 0 and 4. The remainder can be equal to 0. It can be 1. It can be 2. It can be 3. So you have 4 different scenarios. N is 4q plus 0, n is 4q plus 1, n is 4q plus 2, n is 4q plus 3. So these are the representations of integers when you're using different numbers. You can use 5, and then you get 5 different classifications. So what's the meaning of that? Take a look at this. It means that in the world of integers, I can classify the integers by division by 2 into 2q's and 2q's plus 1, even ones and the odd ones. 2q, 2q plus 1. In the world of integers, if I divide integers by 3, I can categorize them by their remainders 0, 1, 2, or in general, I have 3q, I have 3q plus 1, I have 3q plus 2. It gives us different partitions. Now take a look at this. If I divide by 4, I get 4 partitions. 4q, 4q plus 1, 4q plus 2, and 4q plus 3. 2 partitions. 3 partitions. 4 partitions. And so on. Very good. Now we're going to use the representation of integers. Remember that you can continue this process. You can define it for 5. What if we have 6? For 7, we're good because 7 is a prime number. What about if we have 8? What about 9? How many partitions will you get?